So I take this opportunity to introduce our young and energetic resource person of the session, Dr. P. Kumaran sir, to the participants here. Sir is currently working as Assistant Professor, Department of CSE, NIT Puducherry. Before joining here, he worked as a postdoctoral fellow in the Department of Computer Science and Engineering, National Institute of Technology, Tiruchirappalli. He had been awarded PhD degree in the year of 2019 from Anna University, Chennai, India, with the Central Government Fellowship UGC NFOBC. He received his bachelor's degree in the field of computer science and engineering and master degree in the field of network engineering from Anna University in the year of 2011 and 2013 respectively. He possessed university first rank and second rank and received gold medals for both postgraduate and undergraduate degree in state level. He has more than 8.5 years of teaching and research experience in the various prestigious universities in India like SRM University, Shastra University, and Tech University. His research area focuses on social network analysis and social Internet of Things. In connection with his research work, he had published 28 articles in various reputed journals, international conference proceedings, and books chapters, etc., including IEEE, Springer, and also he has 2 patents to his credit. Currently, he is serving as an active reviewer of multimedia tools and applications Springer, Journal of Supercomputing Springer. He is a lifetime member of International Association of Engineers and Institute of Scholars, India. As a personal note, Sir is very enthusiastic and very unique in the way he works. On behalf of the Department of Computer Science Engineering, NIT Puducherry, I invite Dr. P. Kumaran sir to take over the session. Thank you.
Thank you, ma'am, for the nice introduction, and a very good morning to all participants of this 5 days FDP. So, my voice is audible?
Yes, sir. Yes, sir.
Yes, I'll share the slide, ma'am. Please confirm that it will be.
Yes, sir. Yes, yes, sir. Your screen is visible.
Yeah, thank you. So, yeah, thank you, ma'am. So, once again, very hot and good morning to all. So, with the introduction, as per the 5 days of FDP, so my part today is all about conveying the content of data mining, especially the use of data mining in SIoT and IIoT. So I will not say that the word of SIoT and IIoT is just from the yesterday FDP you come across this word, but even though last 24 hours you may be kept on hearing this word SIoT, IIoT, SIoT, IIoT. So in the same way, so today I'll have as a part of this FDP some 1.5 hour discussion in order to convey my content in the hierarchy of IoT followed by SIoT and applications of SIoT, IIoT. So here I took some test cases based on my experience and the area which I work related to SIoT. Then I'll be connecting exactly the use of data mining in this perspective, so that I'll have the 4 main part of today's discussion as per the agenda. So the first level understanding about IoT, everybody understand it is not just that everything exists in the world will be simply named as a thing. And if you have a capability to make a connection between this thing, definitely the thing will have a capability to communicate also. If a communication has been done, definitely the data sharing is also possible. So in that perspective, the concept of Internet of Things, consider that every living things or non-living things available in the world exists as a thing. But is the thing, it's not just the thing, it is a smart thing also. Why? Because it is having a capability of something is called as processing. So how it generally perform the processing upon observing the surrounding environment, and it has to process and it has to give the result. So in that way, if you can see the first level understanding with respect to the Internet of Things, here on the left hand side you can see as per our Venn diagram, which we have generally studied in our basic mathematics. So this intersection point, this is the exact intersection point where you can able to figure it out, the importance of IoT. Okay, so here the things are exist. There the things will have a capability to communicate whatever it can able to capture, and whatever the information you have communicated, you have to process it also. So now, in that way, this is the basic understanding of IoT. It is not exist now. If you can understand the basic network, the purpose of the network and the classification of the network, or that the evolution of the network from client server architecture to a distributed environment to a grid computing to cloud computing, a cloud computing again come back to our fog computing, then fog computing to edge computing. So there you can see some circle. Initially started with the computation with the one device, it will go with the circle, again it will come back to the computation with the same device. That's what you can see, that edge computing scenario now. So in the overall picture, if you can see with respect to the Internet of Things, which is already existing topic. Before that Internet of Things, we are familiar with ubiquitous computing. If you think for a smart office, smart parking, smart home, that time we are come across with ubiquitous computing. But there we faced one important issue. That is that the capability of communicating the device, whatever it processed, will have some limit as per that the type of wireless technology it possesses. What is the capability of that transmission distance? It will go with that Wi-Fi or WiMAX or Bluetooth. So to handle that issue, why can't we think for that the long distance communication? Then they brought the concept of IoT into the picture. By the way, we are relying on internet protocol for communication rather than other Wi-Fi technology. So if you think for that IoT in the market, you are existing with a lot of the smart objects. So this is the word, it is not just the object, it is a smart object. The word of smart will be justified with a different parameter, as like we are saying that the processing capability and that storing capability. Because of the processing and storing, it has to give some result. The result will be called as a service. So in that way, these are all the devices generally exist in the market with respect to IoT. So while ending this topic, one thing I wanted to add, even in that the previous version of the IoT, we have ubiquitous computing or the wireless network. There we have the mobile ADAC network or vehicular ADAC network. Everywhere the one thing is how long it could be able to communicate. So if you are extending the distance by incorporating the IP as that the geo coming to the picture, rather than relying on the other bandwidth, they'll go with that the internet based call. So likewise, if internet based communication can be done, then you can be able to transfer the data which you have captured from one point to even the other end of the world through IP. So this is what the way the concept of IoT coming to the picture. So now for our today's objective is all about where we can exactly figure it out, the understanding of SIoT and IIoT. So that there should be some transformation from IIoT to SIoT, IoT to IIoT, or even we have some more prefixes also along with that IoT. There is something is called as HIoT, Human Internet of Things, and there is something is called as the AIoT, Artificial Intelligence in Internet of Things. Likewise, many prefixes are added in front of our IoT. So with that, one of the prefixes is SIoT. So today I have a discussion for this two test cases related to SIoT and two test cases related to IIoT. So from the test case, you can come to a conclusion that what type of data generally dealt with these test cases. Then you can come to a conclusion of how we can generally handle the data, how far that are, how effective that the data mining techniques are giving their support in this picture. So if you can see this, the transformation of the IoT to SIoT, initially it will be this intranet of things. It means it will be, if you can really understand the internet word, internetwork word, then the concept of intranet is very easy. The way you can see that the process which you are expanding from that IoT, Internet of Things, to Internet of Things, and Internet of Things to social Internet of Things. So this you have to justify in your environment, as per we can say IoT environment. Then you can exactly figure it out that the understanding of SIoT. So what is that the new thing is added in the earlier SIoT IoT? It means the interaction between human to things. So if there is a thing to things and human to things, yes, of course, it will be still will be discussed with IoT itself. But if you think for the interaction between the human to thing, then the concept of SIoT coming to the picture. So what is meant by human to think? Say for example, even as we can see that the devices exist in the IoT have a capability of processing, right? They are having a capability of unique address. With the because of the unique address, they can able to sense the environment, they can process the environment, they can even communicate to their nearby other intelligent devices also. But where the concept of SIoT coming to the picture? If you wanted to understand the SIoT, I wanted to bring some scenario into the picture. Thereby, I will be explaining this with one diagram. So these are all the the things we will generally call that are connected, and this is our normal social network. If you can see, there is a connection between social network into IoT. This is what the word in the last 24 hours, as I said from the last class, last yesterday discussion also you come across with. If you are integrating the social network with IoT, it will become as a social Internet of Things. Even if you are not necessary that the complete social network has to merge with IoT. Even a single social interacted with this IoT environment, that also will be called as the SIoT. But I wanted to figure it out one more word into this picture to understand this point even clear about that social Internet of Things. There are interconnected devices, and the devices will have a capability of communicate, but the communication between the devices will be done based on some relationship, as like our human being. Then this is what the exact point you can able to figure it out, the normal IoT with the SIoT. So I will tell you with the same example. There are people connected here in the social network. Of course, in their connection, they have some relationship in their edge. And there are devices are connected here, but these are all also connected, but there is no as such relationship exist in the edge. So now say for example, this device connected with this device will connected with this. But the question is, as per this connection, we will confirm that the communication may possible, but when to communicate? So to communicate, we have to define some relationship to this edge. Whenever this relationship exists, then you can communicate to this. Whenever this relationship exists, you can communicate to this. So this is what we are ensuring, the things to things communication. Here we are notice that human to human communication. Now even we wanted to connect this edge also with some relationship in order to confirm that the relationship between human to thing. So in the overall point, I can say one information is whenever if you try to bring the concept of SIoT into the picture between two, either the two may be two human or two things or human and things, the relationship is very, very important. So according to the relationship, we have to confirm or we have to decide that when to communicate. So the relationship gives the flavor of how generally the people in the social network will react. I'm a follower of this. I'm a friend of this. Likewise, if you take any real-time social network like Instagram, Twitter, Facebook, every node between two nodes, we can find some relationship. Accordingly, if I'm following someone, if someone is tweeted, I can able to get the data. Likewise, you can able to clearly notice this the information dissemination in the social network that will be completely done based on the relationship between two edges. So the same way we try to figure it out the relationship between a human to thing, then we can able to justify the word of adding social into this IoT. Now you have to ask one more question also, whether the relationship between the human and things is alone the concept of social internet of things. No, because that's why in the box we have a three facility, that human to human is as such social network. They are not connected with any IoT, then we no need to bring that the adding IoT into the picture. But if the human is connected with this thing, or the things also connected with the other thing with the proper relationship, for both the scenario we try to bring the concept of social internet of things into the picture. The one important point from these two pictures is it not necessary that more than one user supposed to be a part of connected with these internet of devices. Even a single person can able to connect with this IoT devices, that also will be justify the word of social internet of things. Okay, so in order to know work with this any real-time applications with SIoT, the first level or the abstract level of working layer architecture is first you supposed to rely on some device, or we will call it as IoT device, and the result of the IoT device supposed to be communicated, and from the result or the communicated data only we supposed to work on it. So what type of work you supposed to do, it is completely depend upon the application. So accordingly you have to design your software. Okay, so now I'll before I can go for some test cases, as I told you, the relationship is very important. For that we have a separate talk for this SIoT is relationship management. You have to exactly figure it out what type of relationship, whether the two device exists in the IoT will have, whether they have a parental object relationship, or same location relationship, or same task executed relationship, or ownership object relationship. Okay, so whether they have a friendship relationship. Likewise, the as I told you, the edge is initially not filled for communication, even though they have a capability of communication. According to that, the justification of the edge only they have to do the communication. Okay, so what the value you will be giving for the edge, that is very important to justify the concept of social internet of things. It means what, the devices will interact to each other without any human intervention, as like a normal social human being. So how the social human being will react if I'll go for a public place, if I wanted to identify some place, I'll be going and interacting with one auto fellow or any persons. I can feel that they are local people. Likewise, you can take any example, how in general a human being will react to other human being. The same way we try to mimic the situations between the devices and also from human to devices. That is the very important point to understand the SIoT into the picture. Okay, so as I have discussed, each and every relationship will have a proper meaning. What is meant by parental object relationship? What is meant by co-location, co-work? Okay, so this you have to figure it out according to the type of applications you used. Okay, so these are all the general applications I can able to figure it out with respect to the application area of SIoT. Okay, so here one small scenario I'll be try to bring with respect to the human activity recognition with the concept of SIoT. Say for example, you can imagine that our day-to-day life, daily life, I'll be giving with some 2 minutes for give that clarity. Say for example, morning I woke up, first I went into a toilet, then I'll take my brush, and after brush I will go to kitchen, I'll take coffee or tea, then I'll go back to my no bathroom for bath, then I come back to my dining table for a food, then I'll go to my suitcase, or I will take my laptop bag or anything, then I have to leave the home. So this is the scenario. I can say that for the first some 2 hours morning routine. So what order I did this? Okay, so I wanted to extract this. It means we will take this SIoT into the picture to justify the point. Say for example, I will be kept the different set of sensor in the places wherever I went. So I have a sensor with the door of the toilet. I have a sensor with my brush. I have a sensor with my coffee tumbler. I have a sensor with my toilet again door, and I have a sensor with my dining table. I have a sensor with my laptop bag holding place. I have a sensor with my main door. If I have a sensor, in all the places, the way I am interacting with these devices, accordingly, you can think for the accordingly it means with respect to the order I have addressed this, or the order I have approached this, I can get to know the clarity of what activity I did, what actually the activity of the human being for the 2 hours in this home. Now you can imagine that the human is interacted with all the object, and once the object will detect such information that this time I have been triggered, then that information will be sent to the nearby node. Okay, so and then the nearby node will it has been sensed, then it has to send the data to the nearby node, or nearby node to all the node. Finally, we have one common control to address that in what time those sensors are triggered. According to, if you are putting that the timing in increasing order, then you will get the clarity of what activity actually human did. Now this is the very interesting application of SIoT. Okay, so we will generally, normally we did this process, but from this we are extracting, there is a concept is called as human activity recognition, using this concept of SIoT. So there we have an interaction between the human to sensor and sensor to sensor also. So likewise, I'll be work with some project related to this SIoT. But initially, if you are working, you cannot able to figure it out whether there is a SIoT exist or not. As I told you, this is again a normal sensors which you are using the sensor to sense the data, process the data, and use the data for some purpose. But we have to figure it out the concept of social existence in this environment. Okay. So first I'll be going for the first test case, which is related to design the walking assistive devices for visually impaired by using SIoT. I will try whether the SIoT will be exist or not. Then you can get the clarity of what type of data will be handled here. Then from the type of data you get from the data, you have to figure it out what the data mining techniques, whether there is a need of data mining or not. You can get the clarity of one by one once you have dealt with this. Okay, so before you can work with any applications, you try to apply the SIoT. First, you have the proper we will call as the background study or history, whether it is actually needed for designing the walking assistive devices for visually impaired. Then if it is actually needed, what was the history behind that, or what was the statistical information? And accordingly, if it is the technology, or if it is the device you wanted to propose, what type of technology you plan to do it. So for that, you have a clarity of the existing technology already available in the market, and what way you can able to come up with the result. Okay, so here if I wanted to go for any visual substitution, then in what way you wanted to design your device, whether it will be worked for what, in which environment, and what is the range it will predict if there is any obstacle, and it will be worked in static object or dynamic object also. Likewise, you have to categorize your work. And also the very important thing is need a proper survey whenever you think for any device you plan to propose. Okay, so as I have found some devices related to this application from two different duration. From 1968, the first devices that are supported for this working assistive environment, to till 2000, I have figured out these devices are exist in the market. And for most of the devices, I will be using that the light and sound are the basic parameter to detect the object. And I have figured it out the work that are approached or supposed to be come up with a product from 2001 to till date. I have figured it out there are applications related to this by using different sensors existing in the market. They are using our GPS technology. They are using our RFID mechanism. They are using our specific object detective parameter exist in our mobile phone video analytics concept. Everything they have to figure it out, and even they have designed there is a separate chair also, wheelchair kind of stuff also. Okay, but in the overall point, the one thing you figure it out is first what level of works are reported for that work you plan to do for it. Okay, so here I, instead of going with that textual description, I just brought some pictorial informations of devices exist in the market. Okay, so then this is the very important thing. Whenever if you wanted to propose something to any particular application, especially in IoT, the first level understanding is you need a clarity of what type of sensor you plan to do, because here in overall IoT, the smart objects are the basic parameter or basic things here. So whenever you can think for a smart object, most of the time it will be the sensor. Not only sensor, the cameras also plays the role, but the sensor is plays a major role under the category of things. So as you can see with respect to this application, as per the first test case, I have figured out these are all the sensor generally plays a major role. Say for example, for some sensor I have highlighted like ultrasonic sensor to identify the distance. We can able to use this by using the concept of the reflection. Whenever it will go in front direction and the sound will hit it with any object, then it will reflect back. By the way, based on the light, the sound, you can able to figure it out the distance, and from the distance you have to figure it out how distance the object is from the source. Then accordingly you have to take the decision. And there are sensor is called as a water detector sensor. And if you are going, this is completely with respect to the visually impaired. There is a water in front of it, and if you have a cane, then you have a sensor attached with in front of it. You can try to find out the existence of water and how depth it is. Likewise, you have figured it out according to the application what type of sensors exist in the market first level. Then you have to study the sensor completely. Why we wanted to study? Because actually what is the sensor, and if it will sense the environment, what type of data it will produce as the result. Because according to the type of data it will produce, you have to think for your computation. What type of data it is? It is the type of textual data, and the textual data in the unstructured form, how you have to plan for a structureness, then how you can plan for the pre-processing of the text, and what type of feature you plan to extract from the text. From that feature, what inference you wanted to make, what knowledge you wanted to extract, everything you have to analyze. By the way, any application you can take as a part of this IoT, you first figure it out the sensor and the working principle of sensor and the data it will be produced by the sensor. Next, you have to figure it out if there are more than one sensors are exist, and you try to find out is there any relationship between these two sensor, whether if these two sensor will be sense the data at the same time, or one after another, or one after another. It means in what situations the another will trigger. For the trigger, whether the first sensor will be plays any role. Likewise, if you try to figure it out some situations according to your application, then if it exists, then you have to figure it out one relationship between these devices. The same way, even for the sensor, you need some user input. Then even you can able to bring that relationship between the human to thing also. Likewise, why I actually the discussion of last 2 minutes, what I did is what way you can able to figure it out the concept of SIoT into the picture. That's all the overall clarity. Okay, say for example, I'll be going with one small understanding of this example. Then I'll tell you what way we try to bring the concept of SIoT into the picture. Say for example, there is a human being, they hold some walking assistive device in their hand, and there is a first information is they try to figure it out with some distance. Is there any objects or exist? To identify that, we try to rely on one thing. One thing, it means I'll call this one smart object. Then from the smart object, I try to identify if there is any obstacles exist or not. Then from the obstacle to me, what was actual distance? Fourth, according to the distance, what way I can able to pass the obstacle without any problem. Okay, so likewise, if you can think for all the process, you have to figure it out the list of sensors you want, what order the sensor has to trigger, or what way the sensor has to understand the environment, and how in what way or what order it has to react for the environment. You have to think for it. Okay, so now I'll be roughly brought one small architecture as a part of the demo which I have shown in the previous slide. So say for example, first I'll have a plan of going with a passive infrared sensor. to detect is there any object exists in my area. Then object exists, then I'll try to trigger my ultrasonic sensor to identify the distance between me and my object, so that I wanted to know have a capability of a rotating facility attached with the ultrasonic sensor. Once ultrasonic sensor will identify the distance, then it has to update. Parallelly, the ultrasonic sensor will trigger our camera also. Say what the camera will do, it has to detect the object, and also it has to identify what is the object it is by using that some camera. Then finally, the data of the ultrasonic sensor with respect to the distance between the object and the what type of object it is, then we will communicate. So whatever the data we are extracted, we have to pre-process and analyze, and we will communicate to the human being by saying that there is an object exists in front of you and this is the object. Now you can able to take a left or right. So this is the information we are giving to human being. And also, if possible, we will also make that the device that will holding all the sensors, that is what we will call as our walking assistive device, right? So the device also should react for it. Say for example, I wanted to take a left, I wanted to take right. Even though I'm informing the same to the human being, parallelly I have to do that the left right action also. Okay, so if you can think for all the process, then you have to figure it out the other computing complexities. How fast the computing complexity is, what type of computing device you try to bring it into the picture, and how that the interaction between one sensor to other sensor, how that the interaction between sensor to human being. So this is one small draft for one small test cases I brought into the picture. From that, what I tried to figure it out, what way I brought the concept of IoT and SIoT into the picture. Here I'll be triggering a sensor one after another, so that I will have try to make a relationship between that devices, and I will have a interaction from devices to human being, so that I try to bring the concept of SIoT. Again, one more time, I will be ensuring the concept of SIoT into the picture. So this is how you should get the clarity of how that the word prefix SIoT added into this picture. The previous example which I have explained about human activity recognition, there also you get the clarity of the SIoT. So where we have interaction between what? Things to things, things to human. So these are all the two primary parameter you have to figure it out with respect to this SIoT. Next, I'll be explaining one more test cases related to this SIoT in agriculture. Okay, so this is a very important area for addressing or try to bring the concept of this IoT into the picture, because the efficiency and improve the productivity and the high amount of yield is very important for any, especially being as a human being. So in this applications, I'll try to bring the concept of SIoT into the picture. Again, the SIoT, it means not just simply SIoT coming to the picture. First, I try to give some automated solution for this application. From the automated solution, definitely for automated solution, if I'm relying on some sensor, then based on the sensor, I try to identify any relationship between the sensor. And if I'm bringing that the human being also into the picture, as like here the human being is a farmer, then I try to figure it out, is there any SIoT exist or not. Okay, so again, for any applications you plan to work, as I can take this particular agriculture application, you first figure it out the type of sensor it actually need for that. If you go with the first level soil, then if you wanted to understand the complete different parameter of the soil, what type of sensors are actually you need. Second, if you think for the understanding of the temperature and moisture exist in the environment, and the supportiveness of that features for the particular crop, you have to understand that. Then with respect to the crop, if you wanted to understand that the root, and you wanted to understand the leaf, you wanted to understand the fruit, then again what type of a parameter or environmental parameter are supported for this. Accordingly, first you have to figure it out for any application, the type of sensor you need and the type of data it will produce. Okay, so these two are the primary thing with respect to handling with any application. Now you can take one small example, the way how you can think for this IoT into the picture. Say for example, here I have took some sensor for identify the wind and the pesticide control and sunlight and for pest and disease prediction and for humidity and for leaf wetness. Likewise, I have some set of sensor for the tree as well as I have some set of sensor for this soil scenario. Now what I wanted to do, I wanted to make this the plantation and this crop yield, so the complete process, this agriculture process in automated manner. So what way I have to do it? With the help of this sensor, I wanted to kept on monitoring this any small tree or any small thing. Then with respect to the with respect to the first level understanding, whether I wanted to pour a water or not, or when I have to pour the water. For that, I should have a control with my water tank. And when I should go for a fertilizer, I should have a control with my fertilizer tank. When I have to go for a pesticide, I should have a control with the pesticide tank. So I have a connectivity now. Whenever the sensor will detect any pest or disease, then it has to trigger the pesticide tank. And according to the pesticide tank, it will pour the amount of pesticides you want. That will be again controlled with one sensor. Again, as per that, the wetness you have, wetness and dryness you have identified for the tree. Accordingly, you have to trigger the water tank. And even for the drip, many technologies are even there for agriculture, especially for the fertilizer tank. You can have a drip technology also. There is something is called as a drip technology also. It means we have to pour the fertilizer to the root directly without wasting. Likewise, overall, again I'll tell you, identify the application, try to find the sensor and identify the importance of sensor for the application. Then you have to think for the relationship between the thing and relationship between the human and thing. So where we have a concept of human and thing, say for example here the disease pest detected sensor will have a trigger with the pesticide tank sensor. So now whether this relationship will be exist always? No. Whenever there is a detection of this, then only it will do that. So that here you have some info. According to the info, this edge will be triggered. So that's why what I'll try to say is, even though without this situation, it can able to communicate. But when to communicate, that is what very important. So when to communicate will be identified always according to the situations. So according to the situations, when to communicate, the when will be ended with the result of the edge value. So now there is a point to trigger. Now there is a point not to trigger. Likewise, the overall understanding of the SIoT is, even though the devices have a capability of communicate, but when to communicate will be depend upon the situation. This is how again the concept of SIoT will be confirmed in this picture. Now here with respect to the tree, I can see that the sensors which are available here and try to find the relationship of try to identify the relationship between the sensor. What way you can think for that human being into the picture? Or what way is it will completely ended with here? No, you can think for it with respect to the sensor, whatever the data you have captured, you wanted to process it. Here I'm just telling, I just explain only about the interaction. And if you wanted to capture some data using the sensor, what way you can able to handle it? You have to think for either you wanted to compute in that place where you have collected your data itself, then it will become as edge computing. Otherwise, you have to communicate the data to the cloud, and from the data from the cloud, you have to process the data and you have to come up with a knowledge, what type of understanding you have with respect to the particular situation. Okay, so even if you wanted to expand this, so this is the first level architecture. If you expand this same agriculture, these are all the basic process. First, you have to collect the data, clean the data, and with respect to the data, see why I have especially have this explanation is whether it is definitely important or not. Today's topic is all about the importance of data mining for IoT and SIoT. By the way, first I wanted to know what type of data I can able to get as the result of SIoT, IIoT. Then only I have to think for the data mining technique. So ultimately, if I wanted to mine something, data is important. So first I have to figure it out the data. Where I will get the data from For that, I have only two words in my hand. One is SIoT, one is IIoT. For that, I have a clarity of what is SIoT, IIoT, what type of data it will generally produce. Then only I can think for processing it. By the way, as you can see with respect to this application, the data is the concern is all about the agriculture text data, farm data, financial data, farmer detail, harvesting data, demand supply data. So with respect to the data, you wanted to figure it out, what you actually wanted to do. Accordingly, you have to fuse the data and you have to come up with the type of the analysis you want. For that, you have to first build a model, or you have to extract the feature. Then you have to build the model. Then you have to predict whatever you want. What is your actual application? Okay, you have to think for that crop yield, or you wanted to identify the disease, or you wanted to go for the any drip technology for your agriculture. Likewise, you can come up with some result. Okay, so I don't want to dig much into this, but I am just generally telling you that what way you can able to connect the concept of data mining into this application. Okay, so now, yes, of course, if you're going for the each and every point as like crop farming, what way it will be important, and especially the data which you have collected, you try to identify the pattern. Other than that, you are relying on the other informations also. Generally, the first level understanding is what level of information you generally expected from the environment about any particular crop. So the rainfall information, leaf fitness information, temperature, humidity, soil moisture. So these are all the things. So once you have to figure it out these things for any application, accordingly what type of sensor exists. Then if you wanted to mount the sensor in the real-time application, according to your objective, you have to figure it out the relationship. So this is how you try to bring the concept of SIoT into the picture. Now the very important thing is whether that the sensor based technology is the only application of this agriculture, because I'm just discussing about SIoT, IIoT component in the picture. If I go with the discussion of only the sensor data is the only chance of making this agriculture more smart, if I can say, then definitely not. If there are works even exist, especially with respect to make this agriculture more smart using image processing also. Okay, so we have a separate works, or we have a separate task or happened about image processing. We have to capture the image, then we have to process the image in order to identify the quality of the fruit, quality of the tree, and the disease in the tree. So that there are many journal paper are published related to that image processing techniques into the picture. So whenever if you have any now plan of working in this application, so if you deal with sensor, or if you prefer going with the sensor will produce maximum the text data. You have to try to incorporate the image also into the picture and try to work with the multimodal data, image data as well as the text data, whatever may be the objective. Whether your objective needs or demands both the image and the text data, then better go with this both. Okay, so I also tell you this point. No, what way this agriculture applications have a relationship with human being. So what generally human being will do whenever, if you think for agriculture, whenever there is crops are planted, they will go for the regular routine surveillance every day. So if you think for in again smarter way, instead of going with the human being for this surveillance, can we incorporate the advanced technology of drones cameras into the picture? We will make that the drone camera for the surveillance, and whenever if you want any pesticide, you can use the drone camera to do the same. And if you wanted to even identify the issues with the image-based image processing technology, which I have mentioned here, that rather than going with the model, say for example, you have to collect the diseased image and you have to identify whether there is a disease exists or not. Even real-time application also possible if you think for the drone camera with the aerial image. So you have a model in your hand, the ready-made model, it will be work for a real time, make a drone camera for a surveillance, and it will detect is there any disease in during that the video it capture. Immediately it has to process in their edge computing itself, and it has to react for it. Likewise, you have to think for this application, but the thinking is fine, but whenever you can going for implementation, then you can come to the problem of the computation capability. Whether no capturing the real-time video, immediately from the video you have to figure it out the key frame, from the frame you have to identify the region of interest of the particular diseased leaf, from from that moment you have to I figure it out whether this disease will have whether this tree or any crop will have a disease. Then accordingly we have to trigger our pesticides tank to make a pesticides, in what level you have to do for it, how much, everything. It is an instantaneous process. Next, as like the human being doing. Okay, that's why recently there is other prefixes are added with IoT, that is AIoT, artificial intelligence in IoT. If I can, being as a human being, if I can do the same process with my pesticides tank with my bag, if I walk, I can find, then immediately I will do. While I'm look at the tree itself, if I can find that there is a diseased leaf, then immediately I can find that there is a disease exists in this tree. Then immediately I have a pesticide tank in my hand. I'll be doing that pesticide. So this is a human being activity. But you can think for, there are crop like a plantation crop, the large area, large surface crop like a coconut tree and tea, coffee, rubber, cocoa. There you cannot able to think for this human being, but still the human beings are doing. And now the drone technology also coming to the picture. Now you have to think that the same situation completely handled by the drone technology. Then you have to bring the concept of a smart agriculture into the picture. Okay. So yes, as I mentioned, whenever if you deal with this the SIoT, especially in the agriculture environment, you may face this issue, especially with respect to that the different sensor will have a different the communication technology, so that you can able to face the interferences problem. Then if you are if you are the costly devices you are placed in that the place like agriculture, it is an open place, right? So you can have a problem of theft and attack with respect to security feature. And even there is outdoor environment related things, you may be a high chance of natural calamity because of there may be a chance of natural calamity. Because of the natural calamity, there is a high chance of damages of devices also. And also this is very important. Again, it is not just like our smart home. We have one sensor for a door, one sensor for a teacup, one sensor for a toothpaste, one sensor for a toilet room, one sensor for a dining table, one sensor for a main door. It is not like that. It is the real-time environment. So you have a lot of sensors to be placed in this real-time environment. If you think in this scenario, how effective the data transmission from all the existing sensors to any centralized point for computation. How about the supporting scenario of the communication technology, on what type of protocol you are using for communications, how effective they are used? What about the power? That is very important. None of the sensor will work without power. So what you have to think, in what way you have to compensate the concept of power into the picture. So if you are thinking for the solar technology into the picture, you have a solar panel. From the solar panel, you try to give the power to the sensor. Then you have to think for the actual execution of the situation in the real time. How complex it is, you can able to think of it. Okay. So likewise, if you can have a vision, you try to bring it, of course. But also, if you wanted to execute it, you have to think for the practical scenario also. Okay. So now this is another test case, the way how you think for using the IoT in the agriculture. So now I'll be giving the one more insight with respect to the healthcare. Now I'll try to take IIoT into the picture. So whether the IIoT will have any uniqueness as like SIoT to bring that the edges are previously not filled with the any relationship value, now it is filled, not like that. Completely using that the Internet of Things to the industrial perspective, then it will become a IIoT. Likewise, in the SIoT, you can have a small deviation of a SIoT with a HIoT, a human Internet of Things. It means the human interacted with the device. There is no as such existence of interaction from device to device, only human interacted with the device. That moment I can able to call this is the situation of HIoT. Likewise, the prefixes that we are added with the IoT will have a small variations. As you can see for this industry, which I have taken healthcare. How about the IoT devices are plays the role? So how about that interaction between the IoT devices, or especially how how effective you can able to run this industry by using IIoT. Okay, so as per that, any application you can go first, you can have some background study. whether what was that the vision of experts will say about this particular industry, and if we are bringing any new technology into it, what was that the revenue, what was that the impact we will get. First you have to figure it out, the basic information. Next, as I told you, any applications you can take. This is the third time I'm insisting the same point. Figure it out that the type of sensor actually demand for the application. As you can take this application, what actually the application? If this is the application, who is actually the entity? And according to the entity, what actually wanted to extract from the environment or from the entity? For that, what type of sensor you want, and what is the purpose of the sensor? What type of data it will produce, and what type of computations you wanted to do with the data. So everything you have clearly analyzed, then you have to think for real-time implementation. As you can see, this healthcare. So definitely there are sensor like the skin electrode sensor for identifying the electrical activity of the heart, and there are sensors for arm cuff based monitor blood circulation, and a piezoelectric sensor for a breathing rate, pulse oximeter for oxygen in blood, skin electrode for frequency of cardiac cycle. Likewise, this is a very limited sensor. It is not only the sensor available in this domain. This is a limited sensor, but I try to figure it out the concept of importance. Then what you wanted to do with the sensor, if you have a sensor, first you try to identify if there is any importance of, or try to find the relationship between the sensor. If it is not needed, only each sensor are independently working and communicating only to the centralized system. What way you try to bring the communication? If you are using any other basic Bluetooth technology through the mobile phone, to GPS, you wanted to connect any type of demand you want, you can able to enable. You can do it. Otherwise, you can see this example. Whatever the sensors which we have, it will be connected with our normal TV, and the TV station connected with our TV station. The TV station is plays the role of interaction through the internet to the monitoring system. Other way, you can even use the mobile phone also. So here this is we already saw from the previous example. Now you can think for the other way of communicating your data also. Okay, so these are all some examples for this application. In what way you can able to think of using this. But the importance of using this IoT, first you have to understand the importance is we try to reduce the medical error if you go with this IoT, because we know we avoid the manual entry, we have to make it as automated entry, and we also identify the patient and we have to track them continuously. And if there is any real-time emergency needed, then we have to give that also. In what way you have to think this word, especially the real-time monitoring. I just brought one more architecture into the picture. This is also the possibly implemented architecture. So again, I'll tell you whatever the architecture which I have shown in detailed way, everything I have worked as a part of this module. So that's why with that I'll be just bringing. So this is architecture I only made during my PhD time, especially for this application. So why what I wanted to tell from this application is what way you can able to ensure the concept of a real-time monitoring in this application using IoT. Say for example, there is a passive or semi-passive patient in the home, and you wanted to monitor them using the sensor as well as the CCTV camera. Whenever you can find that if there is any movement or any importance, you have to identify from them. This is what we will call as a monitoring scenario. Nobody is there. You have to monitor the patient remotely. How effective you can able to bring the IoT into the picture, so that if there is a video analytics is a separate component. If there is a deal with the sensor, the textual handling is a separate component. Accordingly, the type of data you are extracted, you try to figure it out what type of emergency they are belongs to. According to the emergency, you have to find what type of decision you have to make, whether you wanted to inform to that the nearby emergency persons, those who are reported or recorded or stored in your system. You wanted to inform them automatic message. Then you have to inform the nearby hospital. You have to inform the nearby ambulance. Once it has been done, the ambulance will come to the place and they will take and make the ambulance for the better route to reach the hospital. Then again our normal GPS will come into the picture. Likewise, if you think this application, it is not just that small application you can be able to run it in your computer itself. That's why the industrial Internet of Things, social Internet of Things are having the wide variety of, or the space for implementing is huge. So for that I have one truthful or one valid update. There is a work handled by a professor Michael Sheng from Australia. Is currently handling one country, Australia country project about identifying the crowd of people in the public places, and according to the crowd we have to control the traffic system in the complete city. It's a 200 crore project. So 200 crore allotted from the government about the project, and they have a CCTV camera all over that particular city. And according to that, the movement of the people, the capturing of the people, they are walking, and through the other vehicle, they will control accordingly. They have to adjust their complete traffic system. So it is a 200 crore project. Now you have to think again, the SIoT is available there, IIoT is available there. Because what is IIoT in that application? The application is transportation application. That they are used a lot of sensors during the walk, and whether the any vehicle crossed, then the road they have a sensor about to measure the speed, and the sensor they have in that the sideway, they have to measure the speed of the vehicle. Likewise, if you have to think the applications like IIoT, it is not just that the small project, it is a huge project, as like one example I said. Okay. So why I bringing this scenario is what we can able to bring that the remote monitoring in the IoT environment. Of course, this is a one way. So still we have a lot of again, if you execute that the application like this for a real time scenario, there you can able to really identify the complexities, how to get that responses of the video in a moment, how that the sensor data are attached before the patient get into that hospital. We have to send the complete report of complete monitoring. What is their heart rate information, and breathing information, and their heart rate cycle, and their temperature, and their other informations which are extracted from the sensor in the visualized form. So in between that we have some computations. The data will be extracted, and the data will be pre-processed, data will be classified, and the data will be put it into that the proper visualization, and the visualization will be presented to the doctor before the patient reaching to that hospital. So in that way, you have to think for the usage of these kind of the IoT environment to the real world. Okay, so again, so if the previously as I'm talking about data mining is the top view, I can say, but you are digging into that, you will have the a small component under the sub part of data mining is machine learning we have, and from the machine learning we have artificial intelligence technique. Likewise, we have the extended version of computations are available in order to handle that the medical imaging equipment especially. So in the overall concept, if you think for that the IoT, especially the IoT devices in the industry, especially for the hospital environment, so healthcare, the basic expectation from the sensor is sensing the data, transmitting the data, and storing the data in the cloud. From the cloud, you have to analyze the data, and you have to access the data from the different platform. So this is what the basic level of computation we are expecting. Then you have to dig much into it. What level of if you go for a transmitting, what level of communication technology you want for storing, what type of data it is, how much space you want in the cloud, and what about that the transmission delay. And if you wanted to analyze the data, again what type of data it is, accordingly you have to bring whether the text analytics or image analytics, or if there is a video, you have to bring the video analytics. Then what more you wanted to give the data, whether you wanted to access the data from the cloud through mobile phone or through web. So you have to think for all possibility. Likewise, if you can think for that the real time we are exist with some applications like a continuous glucose monitor. There is a device will be available, and it will be attached with the sensor, and the device will sense, and it will be updated through the app which they have developed for the particular application. Likewise, there are as I told, if you think much about, if you discuss, or if you dig much about any application, then you have to come up with where they will actually take that glucose information, and through which transmission technology they will transfer the data, and if they are transferring, and the receiver end is what is available, and from the receiver end, if they are computing the data, then what type of result they, in what way they are giving that result back to the user. So if it is a mobile application, then what type of app it will be available and what is the name of the app. Likewise, you have to categorize the real-time scenario. Likewise, we have the smart infusion pump. It is also one application will be available in the market. Okay, so these are all the supporting components that are related to this particular application from IoT side. Okay, so again, as I have mentioned the 4 steps there, I have detailedly mentioned here. First, you have to deploy the devices, whatever you want for the particular application. Then if you collect the data, then you have to identify the data. It will be not in the form of digital. Try to convert the digital and you have to process it. Once you have processed it, then you have to make it as the standardized form and store it into the cloud. From the cloud, you have to analyze the data and you have to make the proper analytics from it. Okay, so exactly from the portion of analytics, I'll try to bring the concept of how effective the data mining coming to the picture. Again, I'll tell you this is the first version of data analytics, I can say. But going forward, the small port, we have a machine learning component. We have a deep learning component also. If you are feeling that you cannot able to extract the feature from the data, if you feel that it is difficult to extract the feature from the data, then go for a deep learning. Whenever you can make the system to go for a deep learning, you have to confirm that whether you have that much of data. Then you have to think for the reinforcement learning also. The partially we have to make the system to upgrade. And the very important thing is whenever you are dealing with this industrial IoT, as I told you, the first part is transmitting the data. What type of protocol you're used for your transmission, whether you have to go for the MQTT, message to telemetry transport, then how much distance it will transmit, and how about that now if there is a loss of data, what type of error mechanism the protocol will have. And we are very familiar with the TCP/IP protocol. So what about that the protocols in all 4 layers? If you think for application layer, what type of protocol you have, transport layer and on internet layer, and we are merging the last 2 layer data link physical into single layer. What type of protocol you go for it? So if it is a wireless mechanism, and what is type of wireless mechanism you're relying on it. Likewise, you have to go for a real-time implementation. You have to further study the type of data protocol also for a transmission. Okay, so these are all the general Wi-Fi mechanisms available, and not only this. Okay, and with this, I'll be concluding this particular applications with one real-time applications, especially in the current time. We are very much curious about how health we are. Rather than that, we are very much curious about how health our neighbor is. Okay, especially this last 2 year and the COVID scenario. There are many mechanisms are there in the crowd place to identify the temperature of the people using some the thermal camera. And also the same thermal camera, we can also have this kind of environment to detect the temperature of each and every, and we can find some of the temperature is high. Then we can able to if actually who is controlling this, then they will take the decision what they wanted to do. But what I will try to tell you the concept of again SIoT into the picture. What you can able to think is you have a device, and the device will have to capture your temperature, and the same device will be exist around the people those who are having, and it will forward your temperature information to other. The same way that will receive the temperature information of others to you, so that if you are walking in the public place, you can come to know the conclusion of the people those who are around you, what temperature they are. Accordingly, if you're going for implementation, you have a lot of difficulty whether the temperature which you have received is belongs to whom. If you have 5 people around, if it will be given with ID, then which ID belongs to whom? Rather than that, you have to think that there are people around you with some distance you have measured, in that whether there is a person with any high temperature as the primary symptom of this COVID. Then you have to think of avoiding from the place even though you are wearing the mask. Likewise, you can think for the device-to-device interaction, and it has to capture the data of human by the device. So human to device interaction. Accordingly, there is a scope for bringing this SIoT and IIoT into the environment of healthcare. Okay, so it's just a thought process. It may be exist or not, but my point of giving these examples is only to get a clarity of these applications only, IIoT, SIoT, that's all. Okay, so now I'll be going for the one more test case. The fourth test case is related to the transportation environment in the field of IIoT. Again, if I can say IIoT, I stands for industry. So which industry I'm talking about? I'm talking about transportation industry. In the transportation industry, the chance of IoT, then first level I get a clarity is what actually need that particular industry and what type of environmental data they will observe. For that, what type of sensor they want. From the result of the sensor, what actually they will do. The previous example which I have said with respect to the healthcare, I can perform the remote monitoring using IoT. I can perform that the temperature analysis of the people those are around me to identify is there any chance of it. Is not necessary that the high temperature is the COVID, but the last 2 years we figure it out like that only. So we can come to a conclusion of detecting the COVID patient around you using this IoT environment. Likewise, you have to get the result, or I can say what is the purpose you wanted to do for it. The same way, if you can think for this industry, especially the transportation, what is actually the purpose needed in order to incorporate the IoT into the picture. You can think for that the route, or no delivery of a route in better way. You can think for the managing the vehicle. You can also monitor the behavior of the driver as well as the behavior of the wheel that are attached with any vehicle. So there are many applications that are listed here. As I told you, first you have to figure it out any application, what is the need for it. For that need, what type of sensors you want. Okay, then if the sensor will collect the data, then what form of data it is, then from the data what type of analytics you wanted to perform. So this is the first four level information for any application. Okay, so from that, if you go for that the fleet monitoring is the one application in order to know give a clarity of the fuel consumption of any particular vehicle, and the real-time accident response system, and also completely monitor the driver activities, and it also monitor the vehicle also. What way you can able to monitor the vehicle, you can think of it. So you have a pressure sensor, you have a temperature sensor with respect to the wheel, and you have a fuel sensor for the identification of the fuel information. Even though that will be available in front of your the handbar, those the driver, the in front of the driver control itself, you have these informations in the advanced car. Other than that, what we can try to bring. So if we go think for automated vehicle, there is a human is there, and the human no need to drive as like a Tesla. It is automatically drive. How effective it will detect the object around accordingly. How it will take a left, right, turn, everything. And even you can think for there is a vehicle without human being also. Through a remote car you can able to operate. This recently one Tamil movie also we have that thing. But this is something different. You wanted to completely, do some analytics using some camera technology like a rear camera, front camera. You wanted to analyze the data. It is not only capture the data. You want to analyze the data from the data which you have analyzed. You have to respond for it, or you have to extract the knowledge from it. So in that way, you have to think for this application, what way it will be effectively used, and what type of sensors you want. From that what the data will be produced by the sensor. From the data what I can able to make a inference. This is how you should have a clarity of connecting this face by face into that particular application. Okay, so now I'll be get into that the next phase of discussion. So as I have no, it is not only the application. Everybody knows as the first slide which I have mentioned that application. There are many applications I have list out. But here I just took only 4 test cases as per the as considering time is the concern. But I wanted to have the flow to connect. So as you can see, for all the applications, one thing you have to identify what type of sensor you are using. First point. And that type of sensor will produce what type of data. So say for example, here I'll took 2 examples. As you can see, this is the ultrasonic sensor. Okay, so it will detect the object, and from that it will detect that how distance the object from the position where that the sensor will have. Here in centimeter, there is a distance. Now you can come to a conclusion that the data will be produced by this type of sensor as a text data. Okay, it is keep on producing with some time period. So now you can think for these are all the time, and from the time it will be producing, these are all the value. So you can say that y-axis is a distance. Now we can come to a conclusion of from this data, if it is a text data, what type of analytics you can perform. That's what type of analytics you can perform. What for you are actually mounted this data for identify the distance. If you are identifying the distance, what you will do? From that you can come to a conclusion that whether I should go further or I have to take left or right. That is what the overall objective of this particular sensor with respect to the first application I told, for visually impaired, for walking assisted device. Then if the data is as such can be directly handled, then what you wanted to do, you can do it. Otherwise, if you need some any pre-processing, then you have to bring what type of pre-processing you can come into the picture. For that, you should have a clarity of what type of pre-processing is available. For that, you have to get the clarity of what is our data mining. What is data pre-processing? What type of pre-processing techniques are there? In that out of pre-processing techniques, which techniques will be applicable for this application? After pre-processing, what form the data will be available? From the data, what type of inference you wanted to make? Okay, so this is how any applications you can take. Say for example, another application I can take a pulse sensor. Here we have a pulse sensor, right? This is the front and this is the back. And if you mount your hand back, then it will be extracting your heartbeat information. Okay, so as you can see, as per this small application, this will report your heartbeat information to this LCD, LED, the display, as well as in the control of Arduino board. And also, once it will find that the heartbeat goes high, it will immediately inform it will extract your latitude longitude information. For that, we are attached with this technology. Then the latitude longitude information will be sent to the person those names are you are registered with this application to a message by saying that I'm in emergency, my heartbeat is high, this is the current location, please come. Through message you can do. So overall, this is the project will have this the display, followed by we have the GSM technology for a communication of call and message, and we have our a GPS technology for getting that latitude longitude, and we have some buzzer also to give alert to the people those who are around. So as you can see, this model in this picture, this is a project, small project, I can say small huge level project. But here you have to get the clarity of the point is, if you think for the application like SIoT or IIoT, it is not just that the one device is a part. We have a lot of devices in the part. But what I try to say from the picture is, whatever may be the device, first you have to figure it out what type of data it will produce, what type of analytics you wanted to bring. So in that way, you can see the data mining is the concern. You wanted to think for that SIoT or IoT. As per these two examples, you get the clarity. First, you have to figure it out what type of data it is. Okay, so here I have a few more discussion with respect to the data mining, and I hope that this is the FDP. Most of the faculties and their basic and favorite domains are data mining and data warehouse, and they may be studied for last 15 to 20 years. And the recent time they are upgraded themselves with the different machine learning and deep learning algorithm also. So there is no point of discussing much about this type of technique in this picture. But here my overall purpose of taking this talk is what way can you able to connect that what way you can able to connect the concept of IoT, SIoT into the data mining picture, so that I have some basic level of information related to the data mining about the basic data mining, what we can generally understand from the data mining, what are all the basic pre-processing in the data mining, what are all the basic classification techniques in the data mining, clustering techniques, and what type of other data you can able to extract. So I have some the few basic info related to the data mining as a part of this particular talk. Okay, so yeah, this is the point. I will be connecting from the test cases to a sensor and sensor to data mining. So the first level understanding with respect to the data mining is, first, the IoT devices are collecting data. By the way, I wanted to handle the data for the purpose of better decision. Okay, and I wanted to make the automation is the another primary objective. I wanted to make the better efficiency. Because of that, I wanted to make the productivity, especially like application like agriculture. I wanted to make a high accuracy application like healthcare. Okay, so likewise, according to the application, I have a different need. Okay, so and also the very important thing is I need the timely responses also, even though the data is large. How I'm going to handle? So what way that the big data will be handled here? What way that the normal data will be handled here? What are all the forms? So these are all the primary things I can go for the basic understanding of data mining. So whenever if you go for a data mining, the first level understanding is there are many applications demand to mine some meaningful knowledge from the data. Okay, so in order to do that, first you get the clarity of what actually the data, what form it will be available, and whenever if you are extracting something from the data, what you will generally extract. This is the basic definition of the data mining. Okay, so implicit, which is not clearly shown to the outside, and it is not known to previously. So these are all the basic informations are hidden in the data. I try to extract that. So the very old name we are using for the data mining is a knowledge discovery in database, right? So the same way you have to address this application also. If you go for that, you have many applications for this data mining. Okay, so these are all the very old applications. I can say that the market analysis and the risk analysis and the fraud detections. But going forward, as we have discussed, there are some test cases even that also demand the need of data mining into the picture. Okay, so this is the basic architecture of the data mining. As you can see, the basic level, the data, we cannot directly do it. First, we have to perform the different pre-processing tasks like cleaning, integrations. Then from that, we have to go for, we will store the data. From the stored data, we can go for a mining. From the mining, we will get that some meaningful pattern. From the pattern, we will get the proper knowledge. So this is the basic architecture of data mining. Okay, so now if you think for this data mining, of course, we have a lot of process in it, as like we are saying the data collection. And once the data collections we cannot directly handle, we try to think for the different pre-processing techniques exist. After that, we have to think what type of functions you try into the picture. Whether you can go for summarize the data, whatever you have collected, you have to think for a classification or clustering. So this is another important thing. Again, this will decide based on your objective, what you wanted to do for it. Okay, say for example, as I told you, the example, I wanted to go for a disease prediction. I wanted to identify whether this tree will have a disease or not. Then you have to think for what way you can able to handle this. Take the image, identify the image, segment the image. From the segment, you have to try to extract the feature. And if the feature are the important thing for being as a disease, then you can come to a classification. Then you have to figure it out. These are all the diseased leaf. So whenever the diseased leaf is so huge, then you can come to a conclusion of that particular tree is a diseased tree. Then you have to trigger that the pesticide tank to do the pesticides for that the leaf level, and you can also trigger that the tank that are attached with the tree to go for a dig technology. Likewise, the first level, what is the data and what is your objective? Accordingly, you have to prefer what type of operations you wanted to do. And we know that the basic data mining, we have many applications, many actually we can say the influencing factor like the machine learning, pattern recognition, and the visualization, the statistical information. So these are all the basic understanding of data mining. And if you go for mining, there are 4 important dimensions we have. First, we have to mine the data from the different database. It may be the time series data, spatial data, or different form of data. Once you have mined, then the data will be either go for any of this knowledge. Okay, go for a summarization or association, classification, clustering. And again, the technique you can use to for a visualization and what type of applications you have to adopt for it. These are also the primary objective or the different dimension of our normal data mining. Okay, so next, the data is very important. That's what the before I can get into the data mining, the previous slide I have what type of data generally the sensor will produce. So as you can see, the different applications of data mining. First, you have to try to figure out what are all the kind of data you can able to get it. Okay, so here you can see the data streamed from the sensor. This is the primary objective of our task. But the data mining is not only defined for this. That's why the data mining is a common topic. We try to bring the word of data mining in SIoT and IIoT. So now what SIoT, what IIoT, we get the clarity. Then what way we have to apply the data mining into the SIoT, IIoT, we can get it the clarity. But overall data mining, you can see it is not only designed for the sensor data, it can be used for a time series data, graph data, it will be used for the object relational data, spatial data, multimedia data. It will be used for many applications, but we have to figure it out whether it will be used for our application, especially our application of IIoT and SIoT and IIoT or HIoT, whether the type of data which I handled, these mining techniques will support or not. That is the primary task I try to figure it out. Of course, I can see that one of the application of the data mining will support sensor data also. From that, I will get the clarity. Okay, so I'll be good to go with that. Okay. And as I told you, if you go for data mining will support, what type of operations it will generally perform, so that the basic operations I can see some pattern matching, classifications, predictions, what is classifications, what is prediction, how it is actually useful for me, and if I am doing that, how actually, what are all the mathematical things that are beside this, I have to figure it out. Okay. And these are all the some functionality that are associated with the data mining, which you are generally aware of it. Okay. So this is the typical architecture of data mining, whether the data mining is not the standalone part. It is the part will be work along with that our whenever the user is interacted and there is a pattern is evaluated and the data will be made from the database. The databases are available in the different stored places. Then the result will be given back to the user. So here there is actually the flow. From the flow here you can actually figure it out the purpose of data mining engine. Okay, so next these are all the basic use of data mining. So first level, whenever if you are dealing with the data, as you can see the sensor data is primary focus for us. Okay, then rather than to try to find that the first level understanding of the data mining, for the next level we should dig much about, if it is pure text data, then we have to go for text analytics. So we have to dig much about text analytics, and from the text analytics, what are all the statistical test modelings are there. We have to try to explore much about it. Then we try to use it according to our application. But if you can see the basic data processing, pre-processing available in the data. So I have listed some few pre-processing technique like cleaning, integration, transformation, and reduction. And each and every category we are come up with some famous techniques also. But initially the purpose of going for pre-processing is the idea is generally the data which you are collected is not complete data. It is incomplete data, noise data, inconsistent data. Here you have some example for it. But the data which we are thinking with respect to the sensor, it will be not the structured data. First of all, it is unstructured data. So first you try to go for handling the unstructured data to structured data, and even those data does not have any attribute value. So you try to figure it out the attribute value. Then you have to think for according to your application, you can go for what type of class label it belongs to, if it is classification is the thing, or what type of if you go for a clustering, then you have to think for it. Okay, so likewise it is again up to your application. Okay. And if you go for this basic process, each and every process will have a different purpose. If you go for a clean, what generally the clean will do, and if there is any missing value, or if you wanted to smoothen the data, these are all the primary purpose of the cleaning. If you go for integration, the different databases you have a data, how to do that integration. Transformation is if you wanted to get that the data with the common format, you can go for the normalization. If you wanted to get that the space of the data is high, you wanted to reduce the space with the same meaning as per the original data, you can go for a data reduction. And these are all the first level process, and each and every process will have a technique also. Okay, so some of the technique are very famous for a normalization, min-max normalization, mini normalization, you are aware of it. If you go for the dimensionality reduction, you can go for a PCA. So many techniques are even you may be used. Okay, so you have to figure it out exactly for the purpose. Say for example, data cleaning, the very famous method we will follow is a binning method. What is a binning method? How the data will be make it a smooth. So for that smoothing, whether you can go for a mean value or go for a boundary according to the left and right end with respect to the distance, the data will be adjusted. So likewise, you have to, once you come up with the clarity of what type of pre-processing actually the data which you have collected is demanded, they have to think for the corresponding pre-processing. Accordingly, if there are two values available between the two different attribute, you want to identify the relationship according to the change of one value, the other values are changed, or what way it will change, then you have to think for the correlation analysis as a part of integration. And if you go for a normalization, these are all the very famous normalizations we are available with the data mining. That is a very, very important thing. As the data mining is the thing, these are all the transformation mechanisms are all available as a part of data mining. Then you have to need it for your application, then you have to try. Okay, so here you have some value and you have some formula, then this is the normalized value. Instead of mentioning the salary information with this dollar, I wanted to mention all with the scale of 0 to 1, then I can go for this transformation technique. Okay, so what type of transformation you want, you have to apply and you have to come up with a conclusion. As I told you, for reduction, especially the many reduction strategies are there, like the compression. Whenever if you go for a video and audio, this application will be selected. Again, one point here I wanted to tell from my perspective is which one you wanted to go. It's not decided by me. It is decided by the applications, whatever you have selected, and the applications demands what it actually demands. Likewise, you have to go with the basic pre-processing is available, but it is not only the pre-processing. I'm just tell you the clarity. Once you get the data and the data you wanted to do for the further process, if the data demand pre-processing, then the data mining will be available with these set of pre-processing. Then you have to think of what type of pre-processing you can going forward according to that your data. Next, your data is ready, then you have to have a clarity of design the attribute and your applications demand for classifications. Then you have to go for this. By the way, you have a clarity of what is the classifications and prediction. The classification is all about the after you processed what you wanted to go for it. Something is called as a class label. It is already known, right? So accordingly, whenever you deal with the classifications, as per the classification is the concern, the data will be separated into two portions. One is a training set and testing set. Accordingly, we have a proportion of the training and test set also. Okay, you have to follow that the procedure. Accordingly, you have to train your model and you have to give your test and you have to go for it. The same way, if you go for a prediction is nothing but a regression. So you wanted to predict a new value. Okay, so with respect to the previous value. So this is with respect to the prediction, which is available as a part of this classification. In general, if you think for a classifications, there are two steps. As I told you, first you have to go for a model construction, then you go for a model usage. So if you go for model construction, say for this example, first you try to understand so what was the informations are there. From that, what is your knowledge, inferenced knowledge. So this is what we will call as a classifier model. Say for example, here I can found that whenever the rank of the particular scenario is a professor as well as or the either the rank or the year is greater than 6, definitely their tenure period is yes. So this is the knowledge I have extracted. So going forward, if I'll give any test information, then with my previously designed knowledge, I can come to a conclusion that whether it is yes or no. From that, you will get the clarity of what is meant by classification. Okay, that's why the classifications are comes under the first the type of learning of supervised learning. It means the class labels are already known. Okay, so if there is a class labels are already not known, after computing what I'm coming to that, then this is what we will call as unsupervised learning. And the one example is the clustering task. Okay, and under this classification also, before you can go for a classifications, first as I told you, go for pre-processing, then you can go for a feature selection. In that way, you can get the clarity of how that the machine learning will differ from the deep learning. If you go for a machine learning, you have to come up with the type of features that are related to the application. And even for the deep learning, you have to give accordingly. If you are giving the more number of data, even that machine itself will learn the type of feature that are needed to perform the classifications. So this is how the why the deep learning actually demand more data, because it has to extract the feature. For that extracting the feature by themselves, it needs more data to do that. That's why it is not just that going for a deep learning for any applications. If the applications really demand and the applications really have more data, then you can think for it. Likewise, if you go for this classification is the thing, we are come up with a many algorithm. So one of the algorithm is a decision tree algorithm. the overall idea for this algorithm is it has to construct the tree for all the attribute, initially all the attribute at one level, and it has to select the attribute accordingly to form the tree. Okay, so whenever if you give that the test label, accordingly it will come up with the conclusion of what is your objective. So if you wanted to buy the computer or not, it will coming to the conclusion according to the result of the tree. The first level understanding for the constructing of the tree. First, you have to initially I told you everything will be there in the first level. You have to go for which level that the attribute supposed to go. For that, you have to go for some attribute selection measure as a part of this decision tree, like information gain and Gini index. You have to compute that Gini index information gain for the data set which you have collected. Accordingly, with the higher result of the information gain, you can go for the order of node in the tree. Okay, so this is the one classification mechanism, and the other famous mechanism is the Bayesian classifications. Okay, using the concept of probability, we will doing this. Okay, so likewise you have to take some table. So why I'm not giving much information about this? It means this is actually not the task of explaining the data mining algorithm, because I also studied this subject twice, both my UG, PG. I also taught the subject for thrice in my experience. But if it is a subject, I can explain this topic itself for some 2 hours by considering the data. But here the overall objective of this FDP is being as a faculty members, you know that these things are, you are very much aware of it. I'll just give that very light touch upon that what are all the things. Again, it is available for just brush up, and it will be decided according to the applications you want. But the overall point is where it will actually connect. That's what I wanted to tell. Okay, so the other very famous machine learning algorithm with respect to the classification is a neural network. In the upgraded version, you can see that the convolutional recurrent neural network, and this is how you have to come up with the basic classification methods. Other than that, we have other method also. Okay, so these are all the other classification method. Overall, it will be comes under the supervised category. The other way we can go for the prediction is using the other thing in the concept of prediction is recursion. And under the recursion, we have a different recursion: linear recursion, multiple recursion, log linear recursion. From the previous data, we try to predict the new data, especially the recent COVID time. Many paper related to the COVID rely on this recursion model. According to that, the case history in the particular place, case history in the particular area, case history of a particular country, what would be there for the next. So we have seen the usage of this regression model in the last 2 years, especially in the application of healthcare, especially in the COVID time. Okay. So this is with respect to the classifications, and of course in the classification, as I told you, the very important thing is you have to go for the way how you can go for your training and testing. Generally, we'll go with the 80-20, and also you should test your model with a cross validation. Also, you have to split into some 10 sample and make 90 for a training, 10 for test, and you have to change the test into training, make one set from the training to become as a test. This also you have to do. So this is how we have the training, testing, model, and cross validation bootstrapping technique to check whether your model, whatever you learned from the data, will be effectively work for the different test cases also. That you have to ensure as a part of justify or as a part of computing the classification accuracy of your mining. Then the next one is clustering. As I am not aware of what result or what label I'm going to predict, but I have a data, so I try to find that the data which will have a similar interest. So in order to go for that, there are many algorithms are reported under the clustering mechanism. Okay, so you are very much aware of it. Each and every category we have a many algorithm. Okay, but the overall idea is we have to find a similar object, so that the similarity can be identified mostly based on the first level is the distance, so that we are relying on many distance related parameter, and it will be applicable for many application also. Okay, so and as that the result of the clustering is the community, as per that or we will call it as a cluster. As the cluster is the concern, whenever we can say something is a cluster and it is also good, then the data and the distance between that particular cluster should have a minimum distance, and the data with the other cluster should have a major distance, so that we will ensure the concept of a high intra-class similarity low in interclass similarity. Okay, so this is how the quality of the cluster will be justified. And as I told you, there are many approach that are available with respect to the cluster, and each and every application we have a mini algorithm. Okay, and each and every algorithm will work with a different way to come up with this cluster. Okay, and these are all I just note down. The list of methods are available in each and every category as a part of computing our clustering scenario. Okay, so these are all the basic measures which are needed to find the cluster, and this is one small example how it will come up with the cluster. Then the last important point is data type. As I told you, here we are simply handled with this number data as per our sensor is the concern. But even though if it is the audio signal, say for example, there is one application to identify the movement of wild animal in the forest area to living things, we have to go for the acoustic kind of sensor. Whenever we have identified the sound of any particular wild animal, then we have to trigger the camera to capture, and we have to alert the nearby situations about this. Likewise, if we can go for it, then the sensor will identify the sound information. Even though the sound information is identified, what way the sound information is processed, at the end what format the sound information is represented. Likewise, we have a different data types related to our application. But as you can see, the data mining is a concern. It will support for the data type like spatial image. If you think for any applications related to, I have one more application for handling this SIoT in the remote sensing also. But yes, of course, there is a huge use of, say for example, what I can say, you can go for there is something okay. So for malaria, dengue kind of viruses will be detected using vector sensor. Vector surveillance is the one part. Along with that, we have other surveillance mechanism. There they are using this remote sensing concept. So in the remote sensing concept, there is a chance of IoT into the picture. For that IoT, you need the data to be analyzed. For that, the data mining techniques you can apply. Likewise, you can think for this. See, this is some hyperspectral, multispectral image for remote sensing. And if you go for a temporal data, the data also attached with the time information. Yes, of course, that data also will application also, as I said, the first application for human activity recognition. There is a supporting mechanism or methodology available in our data mining also to handle that. So overall, what I can tell in this picture is, first you have to figure it out your application. Accordingly, the application demand what type of sensor. From the sensor, what data you can get. From the data, what type of analytics you wanted to perform. From the result of analytics, what you can able to infer. From the inference, whether your objective gets satisfied or not. So this is how you have to understand the concept of IoT and the use of data mining into the picture. Okay. So with that, the time is 11 o'clock. I'll stop my discussion, and I'll hand over this time to that organization and audience. Now, if you have any query to this, you can ask now.
Dear participants, if you have any query, you can ask, sir.
First of all, I should thank everyone. The point is almost 1 hour 45 minutes. You are being in that line. That is very, very important. With the full support, I have not received any disturbance in between. And I should also thank the organizer, and especially our former HOD and current student affair, Dr. Narendra Rajagopalan sir, coordinator of this FDP, to giving me this opportunity to share my experience related to this area in this Atal FDP.
Thank you, sir. Participants, any queries? Sir, can we conclude the session, sir?
Yeah. Thank you, ma'am.
Yes,
Thanks
sir.
to everyone. Yeah.
Yes, sir. Dedication is not what other expect of you. It is what you can give to others. Not only is the example the best way to teach, it is the only way is a quotes by Albert Schweitzer. The same way, SAR covered all aspects of SIoT with lot of case studies and example. The presentation is flawless and very much informative, sir. The way you started from IoT and then you moved to SIoT, And then it's data mining. It's very clear to understand, sir, with all needed content. You have always been an inspiration in this field, sir. On behalf of Department of CSE, NIT Puducherry, I convey our sincere thanks to Dr. Kumaran, sir, for taking the time to present these bunch of valuable information to the participants. Thank you, sir. Thank you for your valuable time.
Yeah, thank you, ma'am. And most of the audience asking about the PPT. Definitely, I will share to the
Yes,
team
sir,
at the
please
end of
share
your
it.
FDP. They will send that the entire PPT session wise to you. Okay, so many faculties ask about PPT. Definitely, I will share to that the FDP coordinator, and at the end of the 5-day workshop, they will share. Thank you.
Thank you, sir. Thank you
Thank you,
for.
ma'am. Thank you.